Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, August 9, 2021, Monday. Title of talk: Civil Field Engineering Quality and AnnexSL COVID-19 SHE Engineers Role Designs Construction Methods Contracts Organizations Communication Coordination and Quality and Safety. Very important issues for everyone. If you consider issues are important, you have to take their care, and if you don't take their care, you do not do justice with yourself, you do not do justice with public. Certifications of competencies, certification of competencies and certificate of competencies. Not it's mine, it's for public, and there are such thousands and thousands professionals in world and in our beautiful country who got this. Purpose of this certificate is for public and not for individual. There is nothing in these certificates which is addressed to individuals but to people of world. People of world and also people of my country expect something from these certificates, from these personal functionaries holding these public certifications. All these certifications are public certifications because these are issued by or under law. It may be whatever certification, this has certain responsibility, this invests certain responsibility on individual who obtain these certificates, that professional who is expected to be oriented on advanced knowledge, who has certain authority, you can say certain reach on specialization or to some degree of expertise in profession, in subject, in topics. Regarding product standards, regarding product's performance, which depend on quality of product, reserved quality of product I should say, or defined quality of product, and its working, its application, its use by everyone in life. Every person, every citizen, every customer uses whatever product. That product should be based on quantity and quality combination and not simply quantity alone. That should be based on reliability combination, that is application of safety successfully, application of serviceability successfully, application of durability successfully, and applicability of, if caused risk by that product, must have certain solution successfully. So quality and quantity equal product supplemented by safety, health and environment. If product does not give safety or health, safety and health and environment that product has certain defects. Quality doesn't mean quality that harms someone or safety that harms someone. Quality must be intact, that quality which product is expected to have, and that is performance quality, that is durability quality, sustainability quality, continuity, and not that this works for one day, this product, and next day it breaks. Quality, again I say, is to be defined on every product at every stage. It is true that use of product can erode product, can weaken product, which we call wear and tear on product. That is acceptable. but that acceptability has limit. You cannot say today you buy something and tomorrow it becomes war. No, it can't be war. That's what I question on quality. I don't mind if somebody has certification, some organization, institution, or a company has some quality certification. That is only a piece of paper. That is given by competency given by some third party to that company under certain national or international provisions of standardization. That is another point of view. My point of view altogether weighs differently. As a customer, what should I expect? That is my outlook. That outlook should be natural, should be logical, and should be product oriented. I don't expect give me gold, give me diamond. No, I don't expect that. I only expect give me expected quality of product or claimed quality of product only, not more than that, not even a single percent more than that. Because I am a buyer, I pay you basic cost and profit. That clearly justifies, that clearly states, that clearly establishes an existing contract between customer and manufacturer. That contract is a binding one, even though it may not be written. My having bought your product itself is a contract. Until it is free, or it is donation like, or it is gift. This product has been paid to you, and if you have received that sum, which is contract sum or consideration, this product which you gave me, delivered to me, must have certain values, and that value is performance or its successful use for a successful period, with certain definitions which I bracket in with quality. Quality definition applies differently, varyingly from product to product, that I agree. But whatever composition you claim you have put in this, you have built in this product with, you have manufactured this product with, I want that. I want to confirm that this product has. And that is what I say, reliability of product. If your product has that performance level, I shall salute your product, not you. Product has been manufactured under certain circumstances, under certain provisions of your composition or your procedure or definition or whatever we can say there is. Whose responsibility is it? It is your responsibility, because you are a manufacturer or you are a product owner. I am a product purchaser. After purchase, I am owner, but I am owner to use it or to consume it. You are an owner to be fully responsible for my consumption or my use. That is only difference. I am dependent on product because you produce this and you say, you claim, you agree that this is performance level, trusting that, relying on your declaration, I try to use your product, and that product I don't buy because of advertisement or publicity, but because your claim on that product composition. That is also a kind of proposed publicity. You read this and buy it, or don't read and don't buy it. If I read and buy it, this means I accept what you say. That's a kind of quality arrangement between two parties. Party 1, that is customer, and party 2, that is manufacturer. Customer and manufacturer are two parties on purchase of every product or sale of every product. Manufacturer becomes party 2 because manufacturer is like a contractor, and buyer becomes a party 1 because buyer is like a client. There is standing relation between client and manufacturer or contractor. If contractor is unable to perform its job, then client has every right against contractor. This is also called quality relation. There exists a relation between two parties that should be mutually trustworthy, mutually understandable. One should understand other. One should understand needs of others, even if it is not defined. Because you are a manufacturer, you know what is required or what is unrequired. If you do not know, you can ask, you can get feedback. Because individual is individual, but individual is a client, has more authority than manufacturer, than contractor. You may claim anything, you may claim that you have certain rules, for customer rules don't apply until customer accepts them. Quality means customer has given you clearance by payment, expecting reliable performance of product, and if it doesn't do, then customer becomes very unhappy and dissatisfied. You can't expect that customer to move here and there because of your mistake, because of your error, your fault. Don't expect customer to act the way you wish. It is you who has to act the way customer wishes, because it is your fault if quality is not maintained. It is your fault if safety is not maintained. It's your fault if composition is not maintained or falsely declared. It's your fault if whatever is expected doesn't happen. Be clear. Engineering world is only world where quality is very important. Yes, it is important everywhere otherwise, but those are consumables, I can say. Quality of consumable is different, but that is true also. If you buy milk, it should be qualitative. It can be checked, it can be tested. If you buy some tea which is cooked on shop, vendors, kiosk, you have to drink it, and it should be according to your specification. Whatever is within control of customer at time of making it, producing it, that weighs differently because that is consumable. What sort of sweet it is, what sort of rasgulla it is, what sort of gulab jamun it is, what sort of barfi it is, what sort of jalebi it is. These items are manageable. You can have different varieties of sweets because these are also defined, but these are consumables. These are issue of health. Here health is more important. Quality is of course there, because that confectioner can tell you this is quality of this composition of this. But because it is consumable, it is eatable, it can impact your health. That is different. Your health is more important, safety is more important, hygiene is more important. But in those products I am talking, which are not consumables but which are going to be used for long years, long time to come, those products which you buy, it may be electronic product, non-electronic product, it may be other product, it may be furniture, it may be house, it may be whatever highest cost product or lowest cost product, it may be car, it can be whatever. Quality has wide domain. It goes into all areas of production, all areas of manufacturing, all areas of construction. It goes to all places. That's why it's widest divergence in engineering world. We have 15 branches of engineering at highest level engineering. This can be more. I'm just giving certain information that there are 15. Let us consider all branches have certain quality criteria, quality requirements. And in 15 branches there may be 20 subjects in each. This means 300 subjects, 300 criteria requirement, and that is very, very important from every point of view. If so many, you can say 300 requirements, subjects, then they must have every subject some topics, every subject must have many topics, and every topic must have certain defined or expected quality criteria. That's what I'm trying to project, varying requirements, but some are expensive, some are not. For example, you can take whatever expensive item like car, which can be in millions or in crores, or you can take, for example, of aeroplane, aircraft, or you can take even simple example of a lock, a small lock, padlock, or likewise you can say hundreds and hundreds of goods are sold in market. Those must have certain quality, there must be certain structure behind that, and what that structure does, that is important. I cannot claim that every structure is durable, every structure is well organized. I cannot claim that, and I also cannot claim that they are not organized. It's up to that organization that works there, that takes responsibility of that. That organization is important for quality, important for product. We generally say that quality is required everywhere, in every walks of life, in every activity of life, in everywhere, at all locations in engineering. This is a must. This is a must, we say. But does it work that way? And if it does work that way, I welcome it. And if it doesn't work that way, then we have to find some way out. And what is that? We should understand. We understand that, not we should understand that quality and safety, health and environment are two topics, you can say, if not subjects. These two topics cannot be disregarded, cannot be, you can say, dishonored. Even if one likes to dishonor them, it's not possible. These go together. During production, quality can go only when everything is safe, every personnel is safe, every personnel is healthy, and every personnel has certain commitment toward pleasant environment creation. If environment is not pleasant, you will find disharmony, monotony, which are not good for, I'm talking of working environment, I'm not talking of air environment. If that can be handled physically by removing suffocation or by maintaining temperature of room to reduce heat impact, or by application of hygiene all time, so that housekeeping is well done, so that health is well done, and concentration towards activity enhances, so that no untoward work is done, no accident can happen, negligence is avoided, ignorance is avoided, toolbox talks is given, attention is given by safety personnel, so that whole attention goes to quality input, quantity input. I am not saying only quality, I am saying quality and quantity, because both have to run together. If quality doesn't go with quantity, that is not acceptable, and if quality is ahead of quantity, that can be accepted, but it doesn't happen. There can be no work without these two inputs, these two disciplines, quality and safety. I am calling safety, which includes safety, health and environment. It's very big consideration on every activity, and ergonomics science is used for supplementing safety. If that is not used, then there can be different results. There can be tired people, there can be fatigued people, there can be no happiness, no pleasure in work. And there can be no work if there is no pleasure. Work should give pleasure and not monotony. Yes, physical fatigue is another answer for that, but even you are physically sad, physically tired, physically, you can say tired, you have got fatigue degree, you can say that, but you do feel happy, you feel pleased. Oh yes, I worked a lot today. I'm very tired, but I'm very pleased that I could do this work today. I could do better work. I coordinate in best way with others and we produce good one, and I am happy that I could successfully produce quality in that product. That kind of happiness, that kind of pleasure is automatically drawn once you are on job with concentration of producing quality and with safety. And even if you are tired, you don't feel pain because you know you did hard work or smart work. And if you did not do that, you made mistakes, then you will feel painful mentally, if not physically. Oh, I did not do that, I'm not happy. It's not because the salary is impacted, but because of you yourself are not happy internally. I'm talking of internal happiness that works give. There is no work on earth which cannot give you happiness if you wish. Burden, if you think work is burden, then happiness can never come to you. And if you think work is your worship, I try to say work is converted to worship. You enjoy everything because every act in work, every act on job equals it equals to power of worship. Though it may be a personal issue, but I say work should be considered worship, and worship cannot give you pain. And worship stops you from doing bad work to think about good work and do good work. We can say quality has to be complied with. It cannot be forced, but it has to be complied with defined requirements. There is no question of force because it automatically forces you. When it is defined, it is specified, question of forcing does not come into play because it has to be done. When you make a cup of tea, you certainly think of quality. Though it's only a cup of tea, you have to consume it, but you have to see what quantity of sugar I have to add, how much milk I have to add, how much I have to boil, what tea leaf I have to add into this, and then I have to filter it, screen it. So many activities are involved, many activities. Pouring, first of all you have to arrange material, water, tea leaf, sugar, milk, heat, or you can say gas, and they have to decide ratios of this, how much water I have to add and what gram of leaf I have to add. Likewise, you specify everything, and there are many varieties of teas, many varieties of coffees. So what I say, do not think otherwise. You have to define your requirement as a consumer or for consumer. And if you don't do that, your tea won't be sold. Even if it is sold, people shall not come back to you next time because it didn't give them pleasure, it didn't give that person happiness. And business has no future if you don't provide quality. And engineering world is different. Engineering is completely different. Engineering works, first of all, very expensive, very power consuming. It consumes time, it consumes money, it consumes, you can say, material, natural material, which cannot be wasted. This is a sin to waste natural material. Believe me. Keep away. If you have to destroy natural material, this is work against nature. And generally in engineering, natural materials are used, particularly in civil engineering, or you can say in construction world, that consumes major part of your budget. Engineers must realize quality facts, quality requirements. Quality must, and in particular, When you deal with civil engineering works, civil engineers work there, design engineers work there, and all other related professional engineers work there. They have to change quality aspect of society and world, or else quality cannot exist. And if quality cannot exist, material or product cannot exist. Systems quality must be devised, must be achieved. Do not maintain broken system, because broken system means broken life. Broken life means bad life linked to bad system. That system which you originally devised, thought it was excellent one, it was best one, but that becomes worst one. Individual is very important in quality. Individual factor, individuality contributes to quality, and that must be considered very important and significant. Individuals who are professionals, they maintain quality, they maintain quantity together, and they also maintain their knowledge standards, their mark of knowledge. It's not you pass something, time is over. Pass something doesn't mean study is over. Study has to continue formally or informally, because job itself is a study. You get technologies on job, newer technologies come in, you learn them. You learn by experience. You learn by lessons. You learn by so many other ways. Therefore, individuals' improvement, individuals' update on knowledge are significant factors. Professional individual quality to be amended or improved, and one must be forced to amend its quality for reliability achievement by additional teaching and learning, and by additional knowledge dissemination, which is a responsibility of everyone. A relevant element or product defined quality has to be achieved. Attitude of an individual must be streamlined. Streamline here is very important term. Stream of profession, stream of activity must be brought to certain line on which your quality criteria is defined. At least it must be brought to that line. If it doesn't go above that, if it goes above that, it's valued. Individual's dedication has to be applied on actions. You cannot go without that. And if you go without that, you do not work. You just waste time, waste material, waste everything. Commitment towards work is very important. It has to be made. It has to be fulfilled for purpose of successful production and delivery. And all other parameters to deal with what requirements are to be done. Easy to say I designed this. Very easy to say. Okay, you designed it, fine. That is your exclusive input of your knowledge, of your application of experience knowledge, application of theoretical knowledge. But otherwise, experience is very important. Every individual learns something on job. Some learns everything, and somebody doesn't work at all and doesn't learn anything. Structural designs must be decisive, and not only civil structural design, I am saying all other structural design must be decisive, must be quality based, and must be safe, must be qualitative, must be reliable in every aspect. There are various stages of designs which are significant, but merely design does not suffice. Design is not everything in its way. Design process must keep in mind that it has to be implemented, it has to be converted to physical work, physical entity, by construction, by development. If these points are not kept in mind, you can never get what you thought of, what you contemplated, what you designed with. And if construction and developments are not affected, certainly, truly, in line to requirements, to specified mark of quantity and quality and level of total production, whatever you expected, whatever you defined, whatever you required, that level of quality cannot be allowed to be achieved or cannot be allowed to be, automatically, I can't say cannot be allowed, but automatically you cannot forget it, you cannot ignore it. That's what I say, cannot be allowed to be ignored. And generally, if it is ignored, means it is total loss of time, loss of cost, loss of natural material, losses and losses and losses. Work is done through drawings, through materials, through technology, through system, through people, through machines. There are so many sources, so many resources which are collectively used to produce something, to manufacture something, and your communication must be very successful. Design drawings is not, you can say, design drawings is not one discipline. It's very much significant discipline, because drawing is called language of engineers, language of technology, language of profession. If design drawings are not done successfully I mean to say, keep a scheme in your mind, but drawings that are delivered to those who are going to manufacture or real estate constructed, those must be clearly defined without any significant, you can say, mistake, or you can say confusion. Avoid confusion, avoid misunderstanding, avoid clashes, do coordination on that. All these points must be applicable on drawings. Drawings should be well coordinated, well understood, well worked out, well shopped out, which gives support to site people, because site people, of course, they read drawings, they coordinate drawings, but their coordination cannot go to that level as designer can coordinate, because designer fully concentrates on project thoroughly, and without that nothing can happen. That point we have to understand very well. Design is a kind of penance, you can say. Design is a very good concentration. It's penance, it's tapasya. Design is no joke. One has to immerse in that imagination, in that world of mental imagination. Some structure is done, is created in mind, based on mental thoughts, based on concentration, total concentration. And then, of course, it may not be exactly in measurement, but in philosophy it comes in. And then it goes onto paper to simplify everything automatically, and that is working coordination, that stays on paper. Working coordination, shopping coordination, construction coordination, design coordination means you have to stand in a status of a designer, you have to stand in a status of a coordinator, you have to stand in capacity of a site worker. Only then you can bring something real, something actual, factual, working. Of course, with some variations, I can say, but that stage is very important. And this is all part of quality process. It's not quality control alone I am talking of quality system, performance. And system should perform. If it doesn't perform, means that person who devised your system did not know what system should be. If construction is based on reasonable coordination, reasonable design, reasonable input, work quality aspects, practical aspects, experience aspect, there can be no way that design can be transformed to a physical entity successfully. There's no way it cannot be. That's the important point. There's no way that health is not maintained, that safety is not maintained, the environment is not created. There's no way. It has to be. Therefore, I always stress quality of system, quality and system, quality by system. We have to go beyond quality control, and this is what standards we make, we produce, we implement, experience, and then practice everything. If somebody says that we are quality certified, ISO or whatever, you think I bother about that? Never. Yes, okay, thank you. You are certified, you told me, and that is your credit indeed. But this credit has value only if your product claims that it is qualitative. If your product doesn't do that, then I least bother about your third party certification or standard certification, standardization certificate, that your organization operates standards. You may be happy with that, you have certificate, but I shall be happy only as a customer when I get certified working product. Not certified alone, certified by me, I can say. I certify a product as a customer that this product is reliable. I have experienced that, I have used that. That is real certification. How many consumers like your procedure? They like only when material you deliver or product you deliver is well marked. Otherwise, no. All activities must be taken care of, but does it happen? It doesn't happen. Reason can be lethargical attitude, it can be weight of strains in your mind, change of some length and breadth and height in your mind. We call strains, changes from original, that's called strain. If something was say 5 centimeter, then after pressure it becomes 5.01 centimeter. That 0.01 is called strain. That strain should not be with you. And because you are having strain, work should not suffer because of that strain, but it suffers because you are human being, you handle that work. And because deficiencies do exist in designs, deficiencies do exist in construction, in production, design accountability must be fixed, and of course construction accountability would also be fixed. And if accountability on constructed product or element is required, design and construction qualities are complementary to each other, which must be improved. Other which must be improved, and without integrated coordination, activities worked upon shall result in quality-less results, quality-less products. Of course, every day I say method statement is very important. No need to explain again and again. It is very important. Cost is very important. Time is very important. Risks are very important, which you have to know based on your pragmatism, based on your vision. What shall we face as problem if you don't do this? And if you do this, to what level we can solve our problem? This means you have problems input, you have solutions output, and that solution are given by after conducting lot study of analysis, lot study of dependability of this product nature. Then we can say risk can also be classified based on cost, based on time, based on considerations. Risk must be foreseen, it can be foreseen by experienced person. For purpose of resolution, for purpose of removing damages. Damages are not tenable and must be taken care of in advance. Those engineers who are experienced, real experience they have, they enjoy work, they never weep, they never cry. Inexperienced engineers may prove inefficient in such situation because they could not foresee or they cannot foresee. It will take time for their development. You can say risk is very important to be understood. Risk-based emergencies must be understood. Therefore, thorough deliberations or brainstorming must be conducted based on available data input. Risks must be clearly defined to reach its resolution and to convert work convenience to work convenience. Reliability, again I say, safety from all involved factors and serviceability of intended purpose, plus durability of its working life. All other involved applicable knowledge, areas, factors, resources must be understood and achieved in all procedures, or else one should learn before taking responsibility, and all such aforesaid issues must be considered along with possible risks. Analysis and thinking I explained already, engineering I explained already, so no need every time explaining. Quality input and then health. We understand that COVID-19, very big issue of safety. This is COVID that I am really happy to include in this talk sometimes. Issue of COVID-19. COVID-19 has many inputs now, but not based on scientific principles. All world has suffered because of COVID-19. Millions and millions have lost their lives. Crores and crores have suffered throughout the world. More than 1.5 years has gone. And it is really surprising that till today there is no scientific evidence how COVID works. It works. It works very fast. We have given name to it, many names, many subscriptions. Alpha, beta, gamma, delta. I don't know how many more. We have given. WHO calls some interested virus and some serious virus. Means virus of concern and virus of interest. These are all terminological speeches, titles, but we as people don't care for them because we don't understand this. If scientists who are very, very high qualified doctors, if they have not proved anything till now, on relative circumstances, observations are available. Just like this newspaper claims that scientists are still mixed up. They are not clear. They don't know how this virus works. And this virus is that smart, that intelligent. In 2020, 2021, science advanced world, engineering advanced world, still we are off understanding, off reality. This means something is unknown, something is secret. It's like a ghost, I should say that. Devil, I should say that. You can call it superpower, you can say unknown power. You can give anything to it. But fact remains that people have been careless. Fact remains that people have been, you can say, mentally sick. People have tried to avoid it, ignore it. But you think, is that right? Can you ignore it when it impacts your health, impacts your family, it impacts your society? You may say so, avoid it, ignore it, but can it be done? That's why I'm trying to link COVID-19 to safety issues, to medical issues, to human issues. There is no field today that has not been impacted by COVID-19. There is no country today that has escaped or skipped COVID-19. COVID-19 has been very, very secret, intellectual entity that allows no one to understand it. When something is not understood by scientists, by engineers, when something is not clarified, something is not picked up properly, what we say? Okay, let God take care of it. Then we leave it to God. Nothing wrong in that. You can leave it to God because you're a part of God. You are dependent on part God, but this is no solution. If you have solution, it's God given because God gives solutions. And I'm talking of every God. God means God, that's it. No name. But I don't want to jump into that spiritual world. You may say it has gone to living engineering and gone to that world which is not scientific. But which world is scientific? Is this world we are staying in scientific? You consider it? You should not. We are off science as far as COVID is concerned. It may take time, it may not give result, but scientists claim that time will teach us. Time will teach us. Since we are not taught well, since enemy is still there in our rooms, in our homes, in our streets, and walking on road in hot sun, from morning till evening, any time, doesn't give any cautious, any happiness. So what I say, when we talk of COVID-19, it's a part of safety, it's a part of health, it's a part of environment, because our environment has broken, our health system has broken, our housekeeping must be improved, and we should keep ourselves safe. And only safety is face mask, face goggle. That's only this, because now vaccines are also there, people are getting inoculated, but that is limited. That is limited because there are crores of people around the world who have no access to vaccination, and there are crores of people who, due to having personal relations or they can spend money, they can get inoculated. But I think there should be no excitement in that. After all, it's your body, it's your health, it's very important. And if you think of that differently, you can't do anything. World is not that easy as we say it should be. World is not that easy. And safety is really very important in our world. Safety of people and action, how to get away from hazards. In fact, COVID-19 is hazard. Hazard is very simple word, if I can say. It is world hazard. World hazard. Because no definition exists till now. Whatever understanding exists, that is because of assessments, not because of calculations, not because of logical justification. It's because that's what I say. You believe me or you honor my words. It's hazard that started in 2019. It may be whatever kind of hazards, I cannot comment on that, but it's very good hazard for whole world, and it's just taken such a dimension today. We want to hide information of COVID. All countries want to hide. They are interested only in data. They are not interested in anything else. It's a very important point that we could not understand what is this hazard. If you could not understand this hazard, then what is hazard, you can say. What is hazard? Why do you call hazard? It's something, undefined. Hazards are something that's undefined, and it may depend on person to person, from person to person. It's really important point that we have to understand how hazards can be dealt with, how unforeseen can be handled. It's kind of unforeseen, something like this happens, and until it happens and it's experienced, then hazard can be replaced by something else. Important point. We always say job hazard analysis, this analysis. We can say we do that, but is that enough? We were concrete pours, I think we did that. No, this was not that we did. We were at welding, and welding was done. Digital engines were done. Radiography was done. Now we have here you can say pressure testing, highest site radiography we have done. Now it's term of safety, because I have talked on issue of quality, issue of some related safety we have gone through. Now we come to topic that is safety, health and environment. Safety is not so simple. First of all, one should be serious about that. If we are not serious, we shall make others non-serious. Safety is not so straightforward. Safety is not that straightforward. It plays with everybody. It also, sometimes makes someone be serious and risky. Those should not, but persons feel like that, because it gives some bother sensation also. It gives some improper feeling also to everybody. And after all, it's important in all works conditions. It may be work in office or work on field. Of course, work in office is not physically oriented but mental oriented. You have to bear safety everywhere. You have to bear risk everywhere. There is no place on earth where some kind of safety is not involved. It's very important. We have to understand safety input, and that's the reason that I try to collect whatever I can from store of my experience and share whatever right or wrong knowledge I can share with you. I can move it light. Safety is generally for everyone. There should be no one on works who is not safe, who cannot be safe. There can be no one on work. And if there is somebody who doesn't know what does it mean, that person must be first inducted into safety and then brought to site for work. Safety is not civil engineering field, it's field in all engineerings, it's field in all manufacturing, it's field in all types of constructions, all types of factory working. Safety applies to everyone, and it is very important because safety, health and environment and ergonomic support are actually very important. And if we do not maintain safety, we shall of course face strength of opposing material. Safety, if you maintain, safety, you'll be happy yourself that you know what's happening. And if you don't maintain it, then also you know what shall happen. In both cases, there are positives and negatives. But those workers, those you can say real workers, not directory workers, not directors I'm saying, and not engineers as well. No one can supervise these workers all time. You cannot say, stand, I'll see how you work on this grinder. That cannot be done with dedication. Of course, in cases of isolation, you may say you find them through some medium or directly, but jail is jail, arrest is arrest. These are applicable words, terminologies, you can say. I was talking about various activities, and we reached to, after covering many more, like radiations, hazard, other hazards, welding hazards, and likewise we covered many. Now we are going to talk about our item number 9, and that is mechanical communication. Commissioning. It says pressure testing is title here, activity here, and what says bursting of blinds, pipes, fittings under pressure testing. We have to consider pressure test. Well, I think we did it before also. Pressure testing. We did in welding as well. There are so many classes of welding, and we can consider that. I still remember that time we talked of something likewise. Well, I think pressure testing, was it there or no? Hazards controls. There must be document. I think we did it. Let me check if I can find for you, because it doesn't cost much except for seconds. It means sometimes you have to also divert your time to attainments, and it must be there. In that, what was there? I got this list. Definitions regarding certain terms: detection, radiation engine, like a watch, fire watch, page photo, grinding, abrasive cutting, graining, wheel grinding, hazards control, chapter 16. Hazards control, chapter 16, and there's no separate hazard, I think, for this. Working is what was hosting, height hazard, working at height, hazards control, and so this we discussed. Okay, we have pressure welding or stocking. I didn't find that one, so let's try to get it. Pressure welding, pressure versus pressure welding. It is, yes, it's pressure welding. Pressure testing, it is pressure testing. Pressure testing it is, so we can say let's say very important. First I'll say this one. I'll take this first part itself. Let's say pressure testing, and this pipeline isolation, you can say. I got some page, double block test isolation plug. Oh, okay. So I'll show you this. I'll share with you. It's comfortable. I think this is comfort answers, and it should. Maybe it's some company that's cut this way, cut ice, right? And this is here. Now you can see this. Cut this right. Double block and blade test isolating plug. say is safe and effective pipeline pressure testing. Safe and effective pipeline pressure testing. And there's a little explanation, no problem. If it's effective, little is also good. I should not say everything should be according to our wish. We must say this. Safe and effective pipe testing, let us say. Double block pressure testing, I can say here. Pressure testing. I can just save it for better understanding. Positively, we say positively isolate and monitor potentially explosive vapors during hot work. Then effectively hydro test new weld connection with establishment group double block and bleed isolation plug. Dual port design creates a positive pressure barrier between seals, safely isolating hot work from whatever residual upstream gases. In addition, volume of water required for a test is so small that testing can be accomplished using a hand pump. Lightweight aluminum steel construction makes our pipe isolation plug easy to maneuver, often allowing operators to forego use of lifting devices or cranes, which can be high demand during turnaround. Our 8-inch Scazule 80 double block and bleed isolation plug weighs in at just 36 libs of 16.3 kg compared to other plugs weighing in excess of 45.4 kg of same size. Basic operation: after determining pipe and Scazule size, install DBB upstream of hot work area. DBB, that is double block and bleed. Expand seals by tightening compression nuts. Inject inert gas or water between seals, isolation zone, and pressurize. Monitor isolation zone pressure during hot work. After weld cools, release pressure and seal. Reposition plugs isolation zone over weld area, pressure isolation zone. These are basic operations. I will repeat after this. Test pressure is 155 bars G. Upstream pressure rated to 10 psi G or 0.7 bar G. Higher pressure available upon request. And size range is 3/4 inch to 48 inch NPS, DN20 to DN1200. Larger sizes available upon request. Okay. Standard seal material urethane, and feature and benefits: lightweight aluminum and steel construction. Monitor potentially explosive vapors during hot work. Dual port system allows water to be circulated between seals, providing improved cooling during pre- and post-weld procedures. Use less than a gallon, 3.8 liter, of test media, cutting down of fill times and reducing waste treatment expenses. ASME PCC2 Type 4 testing device. And test pressure 155 bar G between seals, available for NPS ranging from 3/4 inch to 24 inches, DN20 to DN600. Pressure tests performed with less than a gallon of water. Double block and bleed application. Block and bleed plugs are found in numerous applications, including oil, gas, and chemical process plant. offshore oil and gas platform, shipyards, plants revamps and additions, piping system and additions, piping systems, pools, pressure vessel with flanged connections, flange replacement programs, performing a pressure test. Let me read first all these pages. There are few steps in that. Step 1. Now perform steps outlined below when conducting a pressure test on 3/4 inch to 3 inches double block bleed. Perform steps outlined below when conducting a pressure test on 3/4 inch to 3 inch double block and bleed isolation plugs. Step 1 is attach hoses to pressure and upstream monitor connection plugs. Then step 2, place plug so both seals are inside pipe you are testing. Step 3, remove residual air between seals if required, if necessary. Step 4, hand tighten hex nut until test plugs grip pipe ID. Slight wiggling of plug may allow for further hand tightening of hex nut. Step 5, using a calibrated torque wrench, tighten hex nut to normal installation torque. Step 6, slowly introduce test pressure. Step 6, slowly introduce test pressure. If performing a pressure drop test, hold desired pressure with pump for a minimum of 5 minutes to allow part to settle prior to closing isolation valve. Step 7, after isolation or testing, application is complete. You can say then, if performing a pressure drop test, hold desired pressure with pump for a minimum of 5 minutes to allow parts to settle prior to the closing isolation valve. Step 7, after isolation or testing application is complete, release all pressure from pipe. Step 8, loosen hex nut until top of nut is at top of thread. And step 9, remove plug from tube. And step 10, inspect plug for wear and replace any or worn component. Now double block and bleed isolation plug. This is that double block and bleed isolation plug. So we can we'll see this later now. Let's go back and see again. So we have to explain this in fact. We should understand this very well before doing anything on this. Title is double block and bleed test. It says isolation plug. Also, I would like to see if more information I can find from here. I think I saved this. I made this file safe. I'm sure I made this safe. Let us see if I made it safe or not. It must be. It must be likewise pressure testing. So I've done it. Is it? I've done it. Pressure testing. Let me see. No, I think I've not done it. Possibly I'm wrong. No, pressure testing, I've done it. Okay. So I've done it. So I'm a little confused with that. So let's go back and see if I can do something else also here. Isolation pipe, likewise I did pressure testing it was. Then we go to proper pressure testing. No, it's video. What is pressure testing? What is pressure testing? It's really important to know. What is pressure testing? We will spend time on this also. Let's say it's good information here. The ground force specialist construction solutions. What is pressure testing? And let us just so we'll talk of this indeed. It's also important. So we have saved this file also. This shall help us. We have to understand this. It's pressure testing. Meanwhile, you can read this. Want to know basics of pressure testing after 10 minutes because of again same issue I'm telling. Okay, what's pressure testing? That's the point you're here. Welcome now, I'll be back here. What is pressure testing? That's the point here. Let us see. And let us go back to see. There's something else. Procedures also we have. Test procedures, and we can say if we can do something on that. Pressure test purpose, procedures, hydro test procedures. Well, I think this is also very long file, maybe. Seven pages. I think we should. Let us see if we can do something from this. We can save this also. Better if we can save and enter share, so that we can save. And this is. We can say this is here. We can save it, and we can say here SC procedures, pressure test procedures. That's okay, fine. Save pressure test procedures, and we can now say okay, fine. We can go back to this and we can remove this from here. So we continue, like we have 3 files more here. I like to well, let's say, what is pressure test? We can say was pressure test. Pressure test, what's that? Want to know basics, want to know basics of pressure testing. It's always useful to start from beginning to understand what this term means. Pressure testing explained as follows. Pressure testing or hydro testing is test in which is a procedure which is carried out after installation of pipeline before it's put into use. Means it's a procedure that's done after installation of pipeline before it's put to use. Purpose of pressure testing is to investigate various limits of pipeline, which test areas such as reliability, maximum capacity, leaks, joints, fittings, and pressures. Without this information, pipe cannot be put into service, and owner-operators have no knowledge if pipe meets set requirements. So very easy. Means we have to test pipe before it's put into use or it's commissioned, and after it is done, after it is installed, we have to test what level of pressure it can take, and how much strong it is, how much reliable it is, what maximum capacity it can take, and what's leakage status, joint fitting, etc. This was required. So the information found from pressure test aids to maintain safety standards and upkeep of pipeline. When there is a new manufactured piece of equipment, pipelines are initially qualified by using a pressure test, hydrostatic test, and regularly requalified at different intervals, which is called modified hydrostatic test or proof pressure test. When testing pipelines, they are conducted under industrious customer satisfaction, filling vessel with an incompressible liquid like water or oil. This examines pipe for any leakage of whatever leakage or changes in shape. Generally, dyes are added to water in order to detect leaks with ease. When pressure testing, amount of pressure put onto vessel is always considerably more than normal operating pressure. This is to allow for whatever unexpected pressure levels on vessel for maximum safety. Information for tester are stamped onto vessel. This may include serial number, manufacturer, and manufacturer's date. There may be other information such as rejection, elastic expansion, and maximum expansion specified by manufacturer for safety. This information is usually recorded on computer system, which allow owner to keep track when tests have taken affected or need be scheduled in to help us remove. Okay, now what is pneumatic testing more dangerous in hydrostatic? Now we can say, however, once you have successfully laid an underground pipeline, I'm just superimposed reading this is. One is pneumatic testing more dangerous than hydros test. Once you have successfully laid an underground pipeline or carried out all required hard work such as welding or post-weld heat treatment, you need to conduct a pressure test to ensure that mechanical properties of pipe haven't been downgraded. However, two primary However, two primary methods used for pressure testing, namely hydrostatic and pneumatic, while former is performed using water, that's hydrostatic, as test medium, later utilizes air, nitrogen, or whatever other form of non-toxic and non-flammable gas to complete inspection, that is pneumatic test. So one is hydrostatic, where water is used as testing medium, and pneumatic, where you can say air or nitrogen or some other form of non-toxic and non-inflammable gas to complete testing. There are other differences between these two testing methods that also need to be considered. Look to choose right option for whatever given application. Interestingly, pneumatic testing is considered to be more dangerous of two options. Amount of energy stored per unit volume of compressed air under test pressure is relatively high. As a result, pneumatic testing is only recommended for low pressure applications, whilst all inspections must feature detailed safety precautions and be overseen by senior staff leaders. You must also ensure that you have approval from relevant authority to carry out a pneumatic test, otherwise you shall find yourself in breach of existing law. This ensures that appropriate condition exists for this type of pressure test. You can't carry out such an inspection if pipeline system is likely to fill with water or unable to tolerate trace amounts of testing medium. What's pressure test for testing a pressure vessel? Whilst there are two distinct methods for pressure testing pipelines, in most instances will be required to use hydrostatic test method. The reason for this is simple. Pneumatic test is inherently more dangerous and can only be used when design of functional pipeline is incompatible with the notion of utilizing water as test medium. When testing pipelines using this method, vessel in question shall be filled with water to help identify whatever potential leaks, mechanical deficiencies, or subtle changes of shape when immersed. Dyes may also be added to water to help detect leaks immediately, whilst you should ensure that welding has been completed and verified before carrying out hydrostatic tests. So in hydrostatic tests, it's very important is the notion of utilizing water as test medium. It's called hydrostatic test. And testing pipeline using hydrostatic method, which will fill with water, pipe will fill, vessel will fill with water to help identify potential leaks, mechanical deficiencies, subtle changes of shape. When immersed, dyes may also be added to water to help detect leaks immediately, whilst you should ensure that all welds has been completed and verified before carrying out hydrostatic test. When it comes to gauging pressure, amount of pressure placed on vessel should always be considerably high than normal operating level. More specifically, it needs to be between 1.5 and 4 of pressure test value to allow for 1.5 to 4, so it's too high anyway, 1.5 to 4 of pressure test value to allow for whatever expectedly high pressure levels that may be placed on vessel during its normal operation. What's pneumatic pipe testing? A pressure test is always required when a new piping system has been completed or instances where individual pipes have been altered. There's a good reason for this too. It guarantees safety of system and reliability of its operation, whilst also identifying whatever potential leaks. Usually pressure testing is carried out after all hot works and weld have been completed on a piping system with post-weld heat treatment capable of downgrading mechanical properties of individual pipes. There are different types of pressure tests that can be used, with pneumatic testing using air or inert gas like nitrogen to pressurize pipeline to 110% of its intended design capacity. Gas is then kept in pipeline for a sustained period of time in order to gauge system's ability to operate safely and efficiently at its maximum capacity. Whilst results produce pneumatic pipeline testing are highly accurate. However, this methodology is only used in markedly low pressure applications where water or oil cannot be used as viable test mediums. Reason for this is simple, as inert gases like nitrogen are capable of storing high levels of energy when they are compressed. During testing, this increases risk of system failure and damage, whilst nature of pneumatic testing requires formal approval from local authority and guidance of specialist engineers. Ground Force are one of UK's and Ireland's leaders supplier of construction industry. Leave it now. See, we'll see. So I think Ground Force has gone. So this I can close now, pressure testing. Now we'll see pressure. What is purpose of pressure testing? Purpose of this, can say, purpose of this procedure is to ensure that pressure testing or pressure tests are conducted safely and effectively. Cover pressure testing of new and they cover pressure testing of new and existing pressure systems or components at a test pressure more than 0 PS. They apply to mechanics, supervisors, inspectors, custodians and subcontractors responsible for pressure tests. Pressure tests are performed to ensure safety, reliability and leak tightness of pressure system. A pressure test is required for a new pressure system before use or an existing pressure system after repair or alteration. There are two methods for pressure tests, hydrostatic and pneumatic. A hydrostatic test is performed by using water as test medium, whereas pneumatic test uses air, nitrogen or whatever non-flammable and non-toxic gas. Hydrostatic test is preferred. The pneumatic test cannot until there is justification of a pneumatic test. Pressure test must always be performed under controlled conditions, following an approved test plan and documented in test record. A single approved test plan may be used for several similar tests, but a separate test record is required. Hydrostatic test procedures. Hydrostatic is the preferred method of testing at whatever company. Now planning is mechanic. Mechanic, supervisor, pressure system program manager, and you can say mechanic. All these are there as sub-disciplines. Recording, inspector, mechanical, mechanic. So let us say what it means. It says now, let's number one, mechanic obtains test pressure after consulting project engineer. Note, when hydrostatic test is performed on an existing pressure system, original hydrostatic test pressure must not be exceeded. Mechanic completes pressure test plan and submits for approval. Then supervisor approves plan. Pressure system program manager approves plan not required for routine testing of existing system. Then you can say mechanic ensures pressure gauges used have current calibration stickers, and again mechanic removes all persons not directly involved with test from immediate test area, and then removes pressure relief valve or non-reclosing relief device from vessel or test boundary where test pressure shall exceed set pressure of valve, or holds down each valve by means of an appropriate test clamp and pressurizes both sides of non-reclosing relief devices, installs temporary higher rated devices where practical, and then a mechanic installs calibrated test gauge so it is visible at all times, and then mechanic ensures skillet blanks or test plugs or clamps are appropriate for use and are free of obvious defects, fills and vent system as necessary to remove as much air as practical, ensures that water used for test is at not less than ambient temperature, and mechanics Pressurizes system, raising pressure in system gradually until the designated test pressure is achieved, and then mechanic maintains this test pressure for 10 minutes before inspection, and if test is above maximum allowable working pressure, reduces to maximum allowable working pressure while making a full thorough inspection for leaks. Mechanic ensures metal temperature at time of hydrostatic test doesn't exceed 120 Fahrenheit, and mechanic, if there is evidence of structural distortion, either rejects system or repairs as advised by inspector, and then mechanic, if there is leak in system, performs following as appropriate, ensures repairs is performed and returns to step 12, and that was pressurizes system, raising pressure in system gradually until designated test pressure is achieved, and then or reject system. When test is completed, vents test pressure to atmosphere and returns relief devices to normal configuration. Inspector records, signs pressure test records, and mechanic completes pressure test record and submits copy to pressure system program manager. Then recording is mechanic submits copies of test plan and test record to custodian. Now pneumatic test procedure. Pneumatic tests are potentially more dangerous than hydrostatic tests because of higher level of potential energy. Pneumatic tests may be performed only when at least one of following conditions exist: when pressure systems are so designed that they cannot be filled with water, when pressure systems are to be used in services where traces of testing medium cannot be tolerated. Using a pneumatic test instead of hydrostatic requires approval by pressure systems program manager. This is formally. In addition to justification, a piping schematic for pneumatic pressure test is required, and diagram is shown here. Important installations of pressure relief valve is required for pneumatic test, and this is your pneumatic test. Nitrogen, helium, argon, compressed air or house air. This is your cylinder for that. Means these gases, pneumatic gases, inert gases, nitrogen, non-toxic gases, nitrogen, helium, argon, compressed air or house air, gas cylinder valve, and this is here regulator for this, and here is relief valve, and this is fill valve, filling system here from this vent valve. So these three regulators are there. One is gas cylinder valve, other is regulator, then it is vent valve, vent is allowed here, and then relief valve, and then fill valve. So how many you see? 1, 2, 3, 4, 5 systems are here. A series of 5 systems, and this is safety manifold. In this are regulator, then vent valve, then relief valve, and then fill valve. This dotted line shows safety manifold, and this is integrated gas valve. Then isolation valve here. Now system starts. Up to here you can see this is typical piping schematic pneumatic testing. Here is this. Again I say this is cylinder, nitrogen, helium, argon, compressed air or house air. This is gas cylinder valve. This is regulator. This is vent valve. This is relief valve. This is fill valve. This is safety manifold, and this is isolation valve, and there is system. Vent valve again, pressure gauge, pressure relief valve, system under test. So this is safety manifold, this is cylinder, this is testing controls, and there is system. In this isolation valve again, isolation valve, which is very important. When there is a problem, you can disconnect this, supply to this one. Then vent valve, like this is another vent valve, then pressure gauge, pressure relief valve, and system under test. So we go further on this. Now what happens? Mechanic again the same. Mechanic obtains test pressure after consulting project engineer and ensures that pneumatic test pressure does not exceed established test pressure of system unless otherwise specified in design documents. Mechanic then completes pressure test plan, including justification for pneumatic testing and a piping schematic for test, and submits for approval. Supervisor approves plan. Pressure system program manager approves plan. Performance. Mechanic ensures that test gauge has a current calibration sticker. Pressure relief valve or non-reclosing relief device may be installed in test medium supply line to ensure that this limit is not exceeded. Mechanic then ensures that test area is properly flagged, barricaded or otherwise controlled to prevent unauthorized personal entry. Mechanic then removes from immediate area all persons not directly involved in test. And mechanic installs calibrated test gauge so it's visible at all time. Mechanic verifies that pressure is continually monitored to ensure that pressure never exceeds designated test pressure of system. Mechanic then removes relief device from system to be tested where test pressure will exceed set pressure of device, or holds down each valve disc by an appropriate test clamp and equalizes pressure on non-reclosing relief device. Mechanic then pressurizes system, raising pressure in system gradually until not more than half of test pressure is achieved. Mechanic increases pressure slowly in steps of approximately 10% of test pressure until required test pressure has been reached. Mechanic reduces pressure to maximum operating pressure before proceeding with inspection. Holds pressure for a sufficient period of time to permit inspection of system. Mechanic checks per pressure gauge periodically for indication of leakage. Mechanic applies a soap solution to accessible welds, screwed pipe joints, flanges, etc. where leakage is suspected. Mechanic, if there is evidence of structural distortion, either rejects system or repairs as advised by inspector. Mechanic, if there is a leakage in system, performs following as appropriate to cover leakage, ensures repair is performed and return to step 11, that is pressurizes system, raising pressure in system gradually until not more than one half of test pressure is achieved, and then rejects system. Mechanic, when test is completed, vents test medium to approve discharge vicinity atmosphere. Recording, inspector signs pressure test record. Mechanics completes pressure test record and submits copy to pressure system program manager. Mechanic submits copies to test plan and test records to custodian and test pressure. There are many types of pressure systems designed under American Society of Mechanical Engineers ASME code and repaired under National Board Inspection Code NBIC. Test pressure of various pressure systems must be calculated based on following: test pressure for new pressure vessel and piping system, as system code hydrostatic pneumatic, boiler power system is boiler power, ASME section 1.5 MAWP maximum allowable working pressure, not permitted pneumatic. Boiler heating, ASME section 4 1.5 MAWP pneumatic, not permitted. In boiler power, in boiler heating, pneumatic is not permitted. Then pressure vessel, ASME sections 8 division 1 division 2. In division 1 1.3 MAWP 1.1 into MAWP, that is pneumatic pressure, is permitted 1.1 times MAWP. In hydrostatic 1.3 times MAWP. In division 2, hydrostatic 1.43 into MAWP, while it's only 1.15 in MAWP. So MAWP is lower always in pneumatic way. Power piping, ASME section B31.1 1.5 design pressure in hydrostatic, while in pneumatics only 1.2 into design pressure. Same way, process piping, ASME section B31.3 is 1.5 design pressure in hydrostatic and 1.1 design pressure in pneumatic. Building services piping, ASME section B31.9 1.5 design pressure in hydrostatic and 1.25 design pressure in pneumatic. And then Sprinkler system, sprinklers in NFPA 13, 200 psi in hydrostatic and 40 psi in pneumatic. So pneumatic is always lower than that. Now able to test pressures for existing pressure vessel and piping system. This was for not pressure vessel, new pressure vessel and piping system, and this is existing one. And now again, inspection, it's a type of work code, hydrostatic and pneumatic. Inspection, alteration and repair. Inspection, the NBIC is code in all these cases. Hydrostatic is 0.9 SV setting. An agreement between the owner and inspector in case of pneumatic. And then alteration, it is 1.5 MWP according to original code of construction. And then repair is 1.5 MWP. Minimum pressure required, verifying leak tightness. NBIC stands for National Board Inspection Code. MAW stands for Maximum Allowable Working Pressure. SV stands for Safety Valve. And then there are forms are required by this procedure. Pressure systems pressure test plan form. A detailed pressure test plan is required for every pressure test conducted at laboratory. An approved plan may be used for several similar tests, and this number is SLAC, the company number, whatever number is I-730, etc. Then pressure system, pressure test record form. It's for separate tests recorded for each pressure test. Then let us test plan and this test record. This was test plan. Now record keeping. Following record keeping equipment. Following record keeping requirements for this procedure. Custodian of given pressure system must maintain copies of test plans and records for 5 years. Pressure systems program manager maintains copies of all pressure test plans and records permanently. That is manager, and references are here. So these are only references, and I close this one. Then pressure testing, what is that? We have to understand that. Positively, what's that? It's really very important. After that, we'll go to hazards. This is only 4 pages, 3-1, I think. Switch on for what? So positively isolate and monitor potentially explosive vapor during hot work. Positively isolate and monitor potentially explosive vapor during hot work. Then effectively hydro test new weld connection with E-stick double block and bleed isolation plug. Dual port design creates a positive pressure barrier between seals, safely isolating hot work from whatever residual upstream gases. In addition, volume of water required for a test is so small that testing can be accomplished using a hand pump. Lightweight aluminum steel construction makes our pipe isolation. Lightweight aluminum steel construction makes our pipe isolation plug easy to maneuver, often allowing operators to forego use of lifting devices or cranes, which can be in high demand during turnarounds. 8 inches casual 80 double block and bleed isolation plug weighs in at just 16.3 kg compared to other plugs, weighing in excess of 45.4 kg of same size. Basic operations. After determining pipe and schedule size, now schedule is very important, schedule size 80. Install DBB upstream of hot work area. Expand seals by tightening compression nuts. Expand seals by tightening compressor nuts. Inject inert gas or water between seals, isolation joint and pressurize. Monitor isolation zone pressure during hot work. After weld cools, release pressure and seal. Reposition plugs isolation zone over weld area. Pressurize isolation zone. This is basic operation. Again, after determining pipe and schedule size, install DBB upstream of hot work area. Expand seals by tightening compression nuts. Inject inert gas or water between seals and pressurize. Monitor isolation zone pressure during hot work. After weld cools, release pressure and seal. Reposition plugs isolation zone over weld area. Pressurize isolation zone. Now test pressure. So we can say test pressure. It is 155 bar G. Upstream pressure rated to 0.7 bar G. Higher pressure available upon request. Okay. Similarly, size range is DN20 to DN100. Standard seal material urethane. Then features and benefits. Lightweight aluminum and steel construction. Monitor potentially explosive vapor during hot work. Dual port system allows water to be circulated between seals, providing improved cooling during pre-post weld procedures. Uses less than gallon of test media, cutting down on fill times and reducing waste treatment expenses. ASME PCC2 Type 4 testing device. Test pressures to 155 bar G between seals. Available for NPS ranging from DN200 to DN600. Pressure test performed with less than a gallon of water. Double block and bleed application. Block and bleed plugs are found in numerous applications, including oil, gas and chemical process plants, offshore oil and gas platforms, shipyards, plant revamps and additions, piping systems, spools, pressure vessels with flange connections, flange replacement programs. Performing and tie-in work as well. Performing a pressure test. Perform steps outlined below when conducting a pressure test. Again I say, I did it before, on 3/4 inch to 3 inch double block and bleed isolation plugs. Now there are how many steps? You can say there are many steps. 10 steps I understand. 10 steps in this. Previously also we talked of this. We speak again, no problem. Step 1. Attach Attach hoses to pressure and upstream monitor connection plug. 1/4 NPT port. Step 2. Place plug. Place plug so both seals are inside pipe you are testing. Step 3. Remove residual air between seals if required. Step 4. Hand tighten hex nut until test plug grips pipe ID. Slight wiggling of plug may allow for further hand tightening of hex nut. Step 5. Using a calibrated torque range, tighten hex nut to normal installation torque. Step 6. Slowly introduce test pressure. If performing a pressure drop test, hold desired pressure with pump for a minimum of 5 minutes to allow parts to settle prior to closing isolation valve. Step 7. After isolation or testing application is complete, release all pressure from pipe. Step 8. Loosen hex nut until top of nut is at top of thread. Step 9. Remove plug from tube end. Step 10. Inspect plug for wear and replace whatever worn components. This is that I discussed before. Vent air is out, water is in. Right? Water is in. It's air, vent is out, that is air. Double block and bleed isolation plug. Where's connection continues. So I can say that I now go to why performing pressure test. This is ASME PCC2 Article 503. Test devices for localized pressure tightness testing of welded repairs. Why perform a pressure test in welding? This is why perform a pressure test that's on welding can say test devices for localized pressure tightness test of welding repairs. Conventional flange to flange pipe weld testing can create dangerous conditions for workers and carry high costs, including downtime, delays and wastewater disposal issues. Grip tight isolation test plug. Grip tight isolation test plug integrates a double block and bleed plug with our grip tight gripper technology, ensuring operational safety and minimizing risk of blowout expulsion due to unexpected upstream pressure in line. Says grip tight isolation test plug integrates a double block and bleed plug with our grip tight technology, gripper technology, ensuring operational safety and minimizing risk of blowout expulsion due to unexpected upstream pressure in line. What is temperature rating of urethane seals? What is temperature rating of urethane seals and shell close proximity to heat transfer area compromise seals during welding process? What is temperature rating of urethane seals and shell close proximity to heat transfer area compromise seals during welding process is a question. Temperature rating for urethane seals is 82 degrees Celsius. When plug is installed, that is 305 mm from weld, distance between weld and double block and bleed isolation plug allows heat to dissipate and decrease to a temperature that is within rating of seals. Question is, shall double block bleed isolation plug accommodate slight weld intrusion? Double block and bleed isolation plug is designed with increased clearance up to 3/8 inch on larger size plugs to allow plug to be positioned over weld for testing even when slight weld intrusion is present on inner diameter of pipe. What can say now? What is average amount of time required to install a double block and bleed isolation plug and achieve a pressure test? After weld area has cooled to an appropriate temperature, double block and bleed isolation plug can be used to complete pressure tests in as little as 10 minutes from insertion to removal. What upkeep and storage conditions are required to preserve quality and performance of double block and bleed isolation plug? Double block and bleed isolation plug requires periodic inspection of O-ring and seals prior to testing. Compression shafts should be inspected and anti-seize should be applied as needed. After a test has been completed, compression nuts should be retracted so seals can fully relax, allowing urethane seals to return to their original size, preventing whatever permanent swelling and or deformation. So I think that's what it was. So we have gone through this file, instant downloaded file, and I go to close this also. So now we come to our file, that is hazards. Pressure testing. Bursting of blinds, pipes, fittings under pressure testing. What are control measures? How to do that? Pressure testing of piping. Pressure testing of piping shall only be carried out by competent and experienced personnel, as we discussed in that method. Engineer was there or mechanic was there, and you can say permanent people were there. Pipe work under test and surrounding area to be barricaded, cordoned off, and suitably warning signs displayed as we understood there. Area had to be cordoned off. Non-testing related personnel shall be instructed not to enter areas where pressure testing is being conducted. A written procedure for gradual pressurization to be developed, that we studied that method statement of certain organization, certain manufacturing company. A written procedure for gradual pressurization to be adopted to develop all fittings, namely sight, glasses, gauges, bursting disc likely to fail under test pressure to be removed. Now we go to hazards. Well, in this there are so many points we already discussed about ASMT testing materials, about double, you can say, connection, that we say that just now we studied that point of double joint. All that are there in pressure testing. We discussed about hydrostatic testing or pneumatic testing. Hydrostatic tests were preferred. Pneumatic testing was only exclusive in those cases where there is no way that we can provide water to that system. Likewise, we studied those points, you can refer to them. Now we come to handling of cable drum. Cable drum, there is hazards of, you can say cable drum can fall and it can trap injuries. Damaged cable drums not to be used. First of all, damaged cable drums not to be used, and vehicles to be located suitably with regard to side traffic, and area for offloading to be barricaded off. Cable drums to be loaded, offloaded using slings of an adequate strength to sustain working load safety. This operation is to be carried out by experienced and competent personnel. Cable jacks to be placed on even surfaces. Cable jacks. Cable drums shall be located on cable jacks of suitable capacity and base designed for this purpose. We discussed other day. We showed photograph of cable jacks. Protruding nails on cable drums to be removed or bent over, either removed or bent over. Cable drums to be checked when stored. I think we had this, we showed to you that one, and if I think it was somewhere in radiography, maybe this is in sketches. Sketches it should be, I am sure. Cable pulling, no, it's not cable pulling. Where's that cable drum? There's some sketch of that. Where's that? It's organization chart, cable pulling, and organization chart again. So it should be here only then. Where is that? Let me see here, female cable drum jack. Oh yeah, I'm sorry. It's there, but this is in power, not there. Cable drum jack. This is in, oh my god, this is in photograph. This is PowerPoint. No, this is image. So I have to show it in print mode. And what's that? You can say it's okay. Yeah, it is that. Cable drums. This is right. I save this file as a mode of cable drum. This is cable drum, cable jacks, I can say. Cable jacks. Cable jacks, alright. So this was that we talked of cable jacks. You can say this is jack here. You can blow it up and see. These jacks must be on even ground. They say these jacks must be on even ground. That's possibility here. So cable jacks to be placed on even surfaces. Cable drums shall be located on cable jacks of suitable capacity and base designed for this purpose. Protruding nails on cable drums to be removed, bent over. What is that? Means there may be some nails here. It should be taken out or bent, that's what it says, so that it doesn't hamper some people. Cable drums to be checked when stored. And also cable pulling. Cable pulling was also, we had cable pulling. What's that? Maybe, I think maybe in this, hold on. Maybe it is somewhere in this sketches, cable pulling. Yes, I think this in sketches, cable pulling, so no problem. I'll take photograph of this again for your use. And that is cable pulling. This is cable pulling here. can see that it goes like this. Cable pulling here. This is just photograph of this, and this was says cable drum falling is one risk in that. Cable drum falling and trapping injuries and manual handling, back injuries, and control measures are personal to wear suitable gloves, footwear, when cable pulling is ongoing or cable pull is going on. Cable jacks to be of sufficient capacity and placed on an even surface. Personnel shall be instructed in cable pulling technique, methods including requirements for ensuring good manual handling methods as well when so adopted. Assessment of weight of cable to be pulled and numbers of persons required to be defined depending on cable weight, calculated or assessed. Cable laying, cable termination. In this also similar hazards: cable drum falling, trapping injuries, manual handling, back injuries. Personnel to wear suitable gloves, footwear when cable laying, terminating cable. Cable jacks to be of sufficient capacity and should be placed on an even surface. Warning signs to be positioned adjacent to cable laying, cable termination areas. Personnel shall be trained in cable laying, cable termination techniques, including requirements for ensuring good manual handling methods as well. When so adopted, cable termination shall be carried out by trained and competent personnel using suitable tools. Permit to work system to be followed to ensure that glands and terminals of cables are on electrically isolated panels. So you can say cable termination. We have seen cable jacks, so we have shown to you full page of this is photo of you may say this is cable pulling, cable jacks, and now we can go to see if cable termination can we get something that's very important. Cable termination I did not do that day. Let us see cable termination. Cable termination, if you can get something of this cable termination. Now there are so many in this, not one images, so many images. Let's say cable termination, what it says. Let's understand what it says is very important. This Tekra tools, cable termination part 1. There are so many in this. Okay, let's go through this, what it says. Maybe it's very important from safety viewpoint, so we can spend some time on cable termination. Let's say cable termination, what's that? Let's come and this we can pay. Okay, cable termination. We can say file save as cable termination here. Cable termination, cable one, cable termination 1. Then I'll take this off. No need now this cable jacks. I can take cable jacks also off. So we are now concentrating on a cable termination because that's important one. Let's go back to other one here, cable termination 1. And type of electrical joints and terminations. This is as cable termination 2 in this. I'm not finding cable termination options. Okay, no problem. Let's say cable termination part 1, techrotools.com. Then engineering electrical equipment auto, types of electrical joints and terminations. Let's say types of electrical joints and termination. Is it very long? I think. No problem. Let's just have a look on this electrical equipment. It's possible. Electrical power cable termination. Let's take a view of this better just for later talk. No problem. If not now, we can talk later on this. So cable termination, we'll call it. It's taking time. Maybe I close it. It doesn't come. Okay, it's come. And let us say it has come, and it has here. It's taking time. It's taken time, but it's come on. Okay, no problem. So 9 pages, no problem. Let us save it. Cable termination here. Let's say cable termination 2. All right. Cable comes together or not? I didn't get saved cable. Why is not getting cable termination? Why am I not getting C here? What's wrong with that? Cable termination. All right. So we have to see first this one. Cable termination 1. This is Tech Alert newsletter. Cable termination is connection of wire. It says cable termination is connection of wire or fiber to a device. Connection of wire or fiber to a device such as equipment, panels, or a wall outlet, which allows for connection or connecting cable to other cables or devices. 3 main areas we discuss are termination used in telecom, datacom, and fiber optics industries. This involves organizing cables by destination, forming and dressing cables, and proper labeling, as well as creating a connection with a copper or fiber conductor. In order to begin, there is planning that must take effect. Prepare for termination by developing a strategy for cable beginning and end. Make sure you have proper tools to complete job. Remember, cable connection is not complete until all terminations are properly identified and labeled. Preparation. Making careful preparations before cable termination effects shall ensure that job is done properly and you save your time and money from onset. Begin by determining where termination point is located. If unknown, make sure each cable shall reach fastest point in wiring closet or equipment room. Next, route cable to this area. Make sure cable length is correct, as well as labeling each cable as you go so you can identify it later. Then form and dress cable by ensuring that cables are parallel to each other. Shaping them into neat bundles using hand tightened cable ties or hook and loop wraps. If cable is too long, make sure to remark newly created and same as before. If cable is too long, make sure to remark newly created and same as before. Once termination area is set up, use proper cable management hardware to act as support and relief. This is important since some cables have specific minimum band radius requirements. Knowing this protect integrity of cable being installed. Now, steps in that of cable termination, that is, copper IDC and coaxial cable termination. Copper, part 1, copper IDC and coaxial cable termination. Insulation, displacement connection, that is IDC, insulation, displacement connection termination. is recommended method of copper termination, that is insulation displacement connection. Recognized by ANSI TIA EIA 568A for UTP cable termination. This is RJ. Now step 1. Determine, this is here, say 1, 2, 3, 4, 5, 6, 7, 8. This is part 3, pair 1, pair 3, pair 4 and pair 2. Determine method and length of sheet removal. Determine method and length of sheet removal. There are several types of tools to choose from when performing sheet removal. Tools used will depend on your personal preference. The budget type of cabling you are using, we highlight some options in tool sections. Here is A, you can see 8 points are here. Same RJ45, this is 5605B, and there is BNC 10 base 2, and this is here RJ45 base T. So that is what it means. It says remove only as much of sheath as necessary to terminate cable pairs and ensure that twist of pair is maintained depending on block type, size of copper cable and type of IDC, that is insulation, that is you can say insulation displacement connection, IDC, termination hardware manufacturer depending on cable block, depending on the block type, size of cable, copper cable and type of IDC, termination hardware manufacturer, requirements differ for correct length to be removed. And 3. Separate, identify and tie off binder groups. This refers to 50 pair and larger pair count cables. By keeping each binder group separated and tied off, it assists in termination and allows for easier housekeeping. Step 4. Fan out and form cable pairs from each binder group. Pairs should not cross or interfere with other pairs. Also, wire pairs should be parallel with no tension at point of connection and equal tension on all connections. 5. Now you are ready to fix to terminal block or crimp to a modular plug. 5A. Termination blocks are hardware designed to house cable mainly for telecom and datacom applications. Although there are many types of termination blocks, most common termination blocks are 66 or 110 style. 66 block mainly is used for voice applications in PBX, key telephone systems and some LANs. 110 block is used in both voice and data cabling applications. Using a 66 block, twisted pairs are fanned through one by one and punched down onto block by termination. Using a 110 block, wires come through center and fan out being punched down into each slot in block for termination. Step 5B. When termination onto modular plugs such as RJ11, RJ45, CAT5, simply feed twisted pair wires into connector while keeping each wire parallel to next, avoiding overlap. Using a ratcheting crimp tool with proper crimp die, simply squeeze hand until you have made a secure crimp. Help ensure consistent eliminate over or under crimping and reduce hand stress. Tools and for use in twisted cable. Now, cable cutting tool. You need a variety of cable cutting tools depending on size of cable you're working with. For small cables, a diagonal flush cutter or round cable cutter works best. Larger cables require a high leverage cutting tool or even a ratcheting cable cutter. Sheath removal tools. Ringing tool, electrician snips, and slitter tool all provide a way to remove sheath on a UTP cable, but each in different ways. Ringing tools is most reliable as it is present to only cut thin outer sheath without damaging wires underneath, while electrician snips are a required trimming tool for whatever termination job. Punch down tool. Select high quality punch down tools with proper blade for type of termination block being used 66, 110, chrome, bits, etc. Don't skimp on this tool. You find yourself using it constantly. Crimp tool. Use only a ratcheting crimp frame with proper crimp dies. For plugs you are using RJ11, RJ45, Cat5. Cat5 plugs often differ from typical RJ45 plugs in that Cat5 plugs have no secondary strain relief indentation in plug body. This is done to help maintain twist in wire repairs as they move through pull plug body. If you're using Cat5 plugs like this, need to use our Cat5 crimping dies when crimping these plugs. Failure to use proper Cat5 will crush plug body and ruin connector. So this was the tool. This is, and then it is, we have punch down tools here. This is stretch, the sheath removal tool, cable cutting tool. We have gone through cable cutting tool, sheath removal tool, punch down tool, crimping tool. Then we can say tools kit, tools cases, coaxial cable termination. Coaxial cable consists of an inner conductor, solid or standard wire separated by a dielectric core from its outer conductor, single or double, braided shield and covered with PVC or plenum-rated outer sheaths. This type of cable is basically used for audio visual but can support data. Predominant coaxial cable are RJ6, RJ11, RJ58, RJ59 and 62. Key steps. Determine proper method and length of sheaths, braid, dielectric and center conductor removal. Start by making a straight cut in termination end of cable. Next, place connecting ferrule over end of cable. Adjust 2 or 3 step coax stripping tool to meet desired cable diameter and stripping requirements. Insert cable into stripper, rotating stripper 3 to 5 full turns. Remove severed sheathing, shielding and dielectric material while inspecting strip quality, making sure there are no strays, strands of braided shield, nicked center conductor or damaged insulation. Step 2. Terminate cable by seating connector system pin on center conductor. Crimp pin into center conductor using a dedicated center pin crimping tool or less desirable small diameter die nest of crimping tools. Step 3. Insert sleeve and connector onto cable. First place connector body onto cable by aligning it so that its shaft fits over center conductor pin and between dielectric and braid shield. Slide connector ferrule up to cover exposed braid shield. Place crimp tool over connector ferrule and squeeze tool until die is completely closed. Connector must be tight, so inspect connection for its neatness and snugness. Using correct crimping die size is critical to proper coax termination. This size is only determined by type of connector used, not size of cable. When specifying proper crimping die, refer to connector manufacturer's specification for recommended crimp sleeve diameter. Tools used for coaxial cable termination. Cutting tool. Tools used for a good set of coax cable cutter. So cutting tools, a good set of coax cable cutter and flush cutter is required when termination coax cabling. We have to be careful not to try cutting steel center conductors with a tool designed only for cutting copper. We recommend use of center conductor cutter specifically designed for this purpose. Coaxial stripping tool. Large variety of coax stripping tools are available. Preset adjustable 2-step, 3-step, etc. for most purposes. An adjustable 3-step stripper work best for widest range of cable and connector types. Now, coaxial crimping tools. Rule 1, Rule 2, Rule 3, Rule 4. And I think Rule 1, always by ratcheting. Rule 2, See, one is always by ratcheting. Rule 2, get a crimper with interchangeable dies. Don't buy an entirely new tool every time you need to crimp a new type of connector. Get a crimper with interchangeable dies. Rule 3, crimp center pin on with a dedicated center pin crimper. Don't use small crimp nest of your crimp sleeve crimper. It simply won't deliver reliability of an 8 or 12 point indent crimper. Rule 4, know proper crimp sleeve diameter for your connector and use matching die over or under crimped connectors are failures waiting to happen. Click OK. Now it is go back to tech alert, return to top page. So this is toolkit. So that's what it was. So we've seen this as an important one we've gone through, and it's really interesting to know some tools for practical purposes. So you should not be surprised to see them in field, and it's very interesting technically to know this. And now we can close this cable termination, and we can close this also like this. These are certain, I can say, we just wanted to see them. In this case, I'm not going to speak a lot on this, but just to see how it works. So I'll take it off first because I taken those. So it's okay, fine. So it's 250. I'll take this now here. Types of electrical joints and terminations back to basics. Here's one. What's that? What is that in this cable? Cable here. Cable plate. This cable plate. Cable gland. This you can see. I'll just blow it up. It's cable plate. It's cable gland. This is core insulation. And this is crimped connector lug. Crimped connector lug. This is structure here. I again say this is axial, and this is cable plate. This is cable gland. This is a core insulation, and this is crimped connector lug. Let's go back to basic with this article by some experimented member of community. He chose to focus on electrical cable joints, and we have played with it. If you too want to publish on blog, leave it. Electrical joints and terminations provide required electrical connections as well as mechanical support and physical protection of cable. There are different types of joints and terminations based on function, type of cable and construction materials. Design is usually influenced by voltage and current that cable carry and operational environment. Electrical power cable termination, this we have discussed here. Electrical cable termination is physical and electrical connection of cable end that connects to another cable or to terminal of equipment. Cable terminations are often designed to enable physical and electrical connections of two cable ends or a cable end and terminal on equipment. Then you can say low voltage cable. This is low voltage cable here, and electrical equipment. Electrical connection requirements relate to voltage drop, current carrying capacity, compatibility of materials, etc. Physical requirements relate to environment protection as well as mechanical security. Methods used to terminate cables vary according to type of cable, type of connector and application. Common type of terminations are crimp connection, solder connection, crimp connection, solder connection, compression termination and wire wrapping connection, direct connection, loop or eye connection, Some factors that determine type are outdoor or indoor use, voltage, current, overhead or underground, type of connector or connector on equipment where cable be connected. Electrical power, electrical power cable joints. Cable joints are used to connect low, medium or high voltage cables. These cable joints are used to connect low, medium or high voltage cables. Type of cable joint, sizes, shapes and configurations vary according to voltage, structure, insulation or voltage, structure, insulation and number of cores of cable to be joined. Joints provide electrical insulation. Joints provide electrical insulation as well as mechanical protection and strength. Electrical connection is made in various ways and can crimp or use mechanical connectors, soldering, etc. Voltage. Joints are designed for low, medium or high voltages and important to match capacity of joint to that of cable. Otherwise a low power cable joint fail if subject to high current. Structure. This voltage joints are designed for low, medium or voltage and it's important to match capacity of joint to that of cable. Otherwise a low power cable joint shall fail if subject to high current. Structure. Cable joints are made according to how cables are to be connected. Simple joints such as straight through connectors are used to connect two power cables at one point, while other more advanced branch connectors may be used to accommodate cable branching of main line or several cables coming into one joint for main cable. There are different cables insulations depending on application of cable, and cable joint must be compatible with cable insulation. To maintain insulation of joint cables, there are varieties of insulation procedures and can be either heat or cold string cable insulation, molded type of insulation or use of tape. Types of electric power cable joints. There are about 4 commonly used types of joints. These differ in mechanical arrangement and where they are used. However, some manufacturers may provide custom designs to suit unique customer requirements. Straight through joints, branch which can be T or Y joints, pot ends, indoor or outdoor terminations. Straight through joint, most used type of joint is used to extend pieces of electrical cables. Typical joint is shown figure 2 below. It's no figure here, unfortunately. Yeah, it's there. I don't know the figure. Yeah, straight joint. 6, 7, 8, 9. This is here. It says where is 1, 2, 3, etc. It's not shown. This is joint here. 3 points coming here, as we said before, and 3 points coming here. So this is a straight joint. It says now here you can say straight joint, and what it says, electrical equipment, type of electrical joints and terminations. So it is riser, earth connectivity connection. One is riser, then earth connectivity connection, CJ compound, plastinet, pouring gate, core insulation, PVC, NA tape, ferrule and BOPP tape, 2 layers, each half overlapped over plastinet. Straight joints can be used for indoor, outdoor, submerged and underground cable jointing. Cast resin based cable joints. Polyurethane based casting resins provide mechanical protection, electrical insulation and moisture imperviousness to joint. Polyurethane based casting. Y and T type branch. A typical Y type branch joint shown. This is used to join low voltage, polymeric low voltage polymeric non-shielded cables between 1 and 5 cores. Branch joining provides a reliable electrical connection, electrical insulation and mechanical properties. Connectors are either compression or mechanical type. Branch joints can be used for indoor, outdoor, submerged and underground cable jointing. This is a branch joint. The branch, Y-type branch joint, Y-type, Y here, and this is here. Y-type, this is here in Y-type. Okay. Design has a mold body construction with seals and fixing clips. This makes it easy to do jointing, while sealing eliminates need to tape joint. Pot and joints. Pot and joints are used at live voltage cable ends. In a typical cable, each of course is sealed separately using a heat shrink cable and caps. Screen bandage is then applied to provide for earth fault protection, and combination is then covered with thick wall of heat shrink cable. Pot ends joints are suitable for temporary and permanent cable abandonment to provide safe termination of live power cables for indoor, outdoor as well as underground cables. Now what's summary? Cable joints and terminations provide a means of making reliable electrical connections between different cables or between electrical cable and terminals of equipment. There are several standard type of cable joints and terminations. However, manufacturers can make tailor-made joints to suit different technical requirements. Requirement for joints and terminations that they should meet standards in terms of electrical mechanical properties, insulation, earth continuity, environment protection, and also in terms of electrical and mechanical properties, insulation, earth continuity, environment protection, and more. So I think that's what it is. So our paper has gone. So we can say we learned something about cable jointing in this way, and it must be appreciable. So we can close this and say what is that cable jointing in this: cable laying, cable termination, and there are hazards, cable drum falling, trapping, injure, just manual handling, back injuries, and says personal to wear suitable gloves and footwear, and cable laying, termination cables, cable jacks to be of sufficient capacity and should be placed on an even surface, warning signs to be positioned adjacent to cable laying, cable termination areas. Personnel shall be trained in cable laying, cable termination techniques, including requirements for ensuring good manual handling methods as well. When so adopted, cable termination shall be carried out by trained and competent personnel using suitable tools. Permit to work system to be followed to ensure that glands and terminals of cables are on electrically isolated panel. And then material handling is different. Our electrical part per quality system has been explained. It's very important. I have to explain everything that quality system desires and tells. It's not easy, but it is to be done that way. And I think that's time to probably stop, as 3 hours have gone. We have to system is about job, hazard analysis and assessment. This is what we are doing in details by understanding the hazards, because we have to understand activities first. If we don't understand activities, how can we know what hazards are valid and what hazards are not valid? That's point of importance here, and that's the reason I'm trying to include as much information as possible into these FT tasks, because just naming, we cannot simply answer questions. We have to understand everything. That is major point here. We have to understand each point correctly. Only then we can say that we have done it. So what we have done is simply not just say that. Still we have many pages left. We have here, we can say we were here. Material handling, we have to do it. Manual handling it is, and it is now 13 we have to study. That is manual handling. Then we have here handling of steel, handling of timber. We have concrete pours, then steel fixing, civil work, backfilling of excavations. We have then transportation, lifting of heavy equipment, and we have after that scaffold, temporary works, scaffolding, then maintenance of scaffolding, dismantling of scaffolding, hazardous substances. We have use of hazardous substances, then erection of fencing, fabrication of gates, after that erection of gates. We have removal of waste material. Then we have erection of steel work. We have installation of pipeline and valve fittings. And then we have electrical work, rock drilling, civil works, rock blasting, site preparation, site transport, and I think that's it. So what I say, we have to understand. Safety is responsibility of each and every one. This is very important point, and we understand in our statement of quality what we have said. No safety, no pain, and no safety, no pain. You know this one. Very important. And quality system in safety, actually we are talking in. We are trying to explain what is required in system of safety to an extent. Quality of safety is maintained. So that's an important point, and we like to close it now. Only point that I was interested in, that quality and safety, health, environment, ergonomics must be taken care of by everyone. It's important, cannot be ignored, and if we ignore ourselves. That's another point, we ignore ourselves. That we have to think of. It's not simply that we can just just move on. No, it's not that. We have to understand every activity before just doing that. It's very important from this point of view. I say let's close this now and see how shall it work. So now I stop it. Thank you very much.